It's my pleasure to chair the next session, which will feature three speakers. We will be starting off with Ivan Seskar. Ivan Seskar is the Chief Technologist at WinLab, Rutgers University, responsible for experimental systems and prototyping projects. He's currently the Program Director for the Cosmos project, responsible for the New York City NSF power deployment, the PI of the NSF Jenny Wireless project, which resulted in campus deployments of LTE and WiMAX base stations at several US universities, and the PI of the NSF Cloud Lab deployment at Rutgers. Ivan has also been the co-PI and project manager for all three phases of the NSF-supported Orbit mid-scale testbed project at WinLab. He has successfully leading technology development and operations since the testbed was released at a community resource in 2005, and for which the team received the NSF Alexander Schwarzkopf Prize for Technological Innovation. Ivan is also a co-chair of the IEEE Future Networks Testbed Working Group, a senior member of IEEE, a member of the ICM, and a co-founder and CTO of Upside Wireless. Ivan, without further ado, take it away.
Yeah, hi everybody. Thank you very much for the introduction. I hope you can hear me and you can see the slides. And let me see if I can even enable the camera.
We can hear you, and we can also see the slides.
That's good. That's the most important. The camera is not, to see me, it's not that important. Okay, so first of all, let me start by sort of saying that this is the work, as pretty much everybody else before me was presenting, of a lot of people, and I tried to acknowledge everybody, and I'm sure that I missed a few people. But nevertheless, the talk is going to be about the sort of use of public, and in this particular case, academic testbeds for functional performance and interoperability testing that two of the large open source projects in telecom sector, the ONAP and ORAN, are actually trying to sort of steer us towards. And then, of course, I will repeat some things that Tommaso was talking about in the morning, and hopefully be able to skip and save some time because we are running a little bit late. So let me first go into the sort of this notion that's being shared widely right now, and that is that virtualization and open source approaches that we are seeing happening in the telco industry are actually creating a fairly significant disruption in the whole ecosystem, right? So the first objective of this process is to retarget existing components to become software-based, right? And that's something that most of the vendors were not necessarily ready for. But it also creates an interesting research topic, so I just want to put this up front because I'm not sure if I'll remember towards the end. This actually creates a problem for us to work on, that most of these processes are going to create energy consumption problems because the software-based stuff tends to be a little bit more power hungry than when you talk about ASICs, right? So we have to, as a research community, we really have to keep an eye on this. Now, the idea is, of course, to then look into this new hardware components that one can create. And actually, you're starting to see a sort of these custom accelerators that are being developed by various companies to sort of address in part this energy consumption problem that these new disaggregated systems are bringing up. And then again, commodity off-the-shelf servers are something that people are trying to use in all of this. And ultimately, the main benefit is supposedly in this service disaggregation, right? That these processes and the creation of open source stuff is going to enable. Now, things that this is sort of introducing, that is something that the vendor community at least didn't spend much time on it, but also the user community now has to have an input in, is that this requires a non-trivial coordination with other standards, and there are a lot of standards that are involved in creation of telecom systems these days. Ultimately, how to achieve interoperability, suddenly you have a huge expansion of the space of people who are working on these both hardware and software elements. And then user community is creating new deployment scenarios, which are, and you can talk about verticals or more interestingly, about people deploying applications, which are going to change the way that the equipment is actually operating. And ultimately, you need to make sure that this is really all standardized and certified in a certain way, and therefore creates a problem for existence of independent certification and badging institutions. Now, just very quick overview. So Linux Foundation networking projects, there are a lot of them, and they have all these acronyms, and you heard Tommaso was quite successful in explaining some of them, at least as far as ORAN is concerned, right? And I don't have time to go through all of this, but I just want to sort of flash the slide to sort of outline the most important ones. So the top two, the OSM and ONAP, are management or orchestration frameworks that are open source. And when we say open source, that doesn't necessarily mean that you can get the source code. Keep that in mind. This is a telco industry. Therefore, chances are you will have open interfaces and be able to interoperate with these components, but you will not necessarily get full access to the source code. Now, the bottom three are Open RAN, vRAN, and ORAN are, depending on who is the vendor behind them or main vendor behind them, are three of the projects that are focused on radio access networks. And again, these are just quotes from their websites and then readily available information about all these open source projects, right? Now, the two architectures that I will be talking mostly about, or two open source projects, are the ONAP and ORAN, right? So as you can see here, the orchestration framework, ONAP, it's an open source project, but it's of course pushed mostly by AT&T, and now of course including a lot of other vendors that are participating. And it focuses on orchestration and management. And you can see there are a lot of different components. It's really a sort of a huge forest of acronyms that we don't have time to go through, but nevertheless, the point is that this is sort of a architecture that's put on top of the cloud, right? And again, there is no real time here, at least not in a traditional sense that you have a tightly controlled closed loops, but it does have a requirement to interoperate with a large, huge framework of functions and capabilities. The ORAN, we heard this morning more about this, so I'm not going to spend much time on it, other than to say that the focus so far, I mean, there are some open source implementations of near real-time and non-real-time RIC, but the focus of the industry is mostly still on this notion of front-haul testing, meaning interconnectivity between ODUs and ORRUs, right? And I'm sorry if I'm speeding through all of this just in order to catch up some time, but if you have any questions, please feel free to reach out offline, and I'll be happy to answer as many of them as I can. Okay, so ONAP, right? So they were the first one that started about 5 years ago. They came to a conclusion that they need to create an interoperability testing lab. And they drafted the guidelines, as this is the web page. They drafted the guidelines as to how this interoperability things have to look like. And they approached, of course, two of the, at that time, existing labs, right? The first one was Orbit, and a little bit later on, they approached the Powder Lab as well, when it became available, to sort of ask if these two labs can be used as a sort of a place where testing and interoperability and development can actually happen. Now, ORAN went a little bit further away, and I'm now mixing timelines here, but you know, the ORAN specification actually went really, really far in terms of specifying something that's called the OTIC. They call it Open Testing and Integration Centers, or ORAN Test and Integration Centers, depending on who you ask. And they outlined really the objectives as to what they want to see in these constructs, right? So the idea is to sort of look at the two major functions. One is the certification and badging and plug fest, where you sort of show that equipment behaves the way it should be, it conforms to standards and achieves certain performance, but also create something that's called a POC, or proof of concept, that will allow people to, in sort of create a demonstration of new functionalities and new capabilities, right? And again, of course, they formalize this fairly seriously in the sense that they have all the rules and regulations that are supposed to happen. But arguably, the most important attribute is the openness, right? So they really, really want to have these open. And of course, if you talk to the vendors, you know, vendor A would never go into the lab of vendor B. So they were sort of looking for the Switzerland of vendors, right? And that's not possible to find. So they came back to Platforms for Advanced Wireless Research, right? And so I'm assuming that people are familiar with the POWER program, just to sort of say that there are now four deployments, right? The first two were Powder and Cosmos in Salt Lake City, New York City. The airport was the third one in Research Triangle, and then of course ARA was just recently announced this summer. And on top of that, we have also the Colosseum and OpenAirX Labs, which are sort of focused on 5G end-to-end testing, right? And so the idea is that both Powder, and I'm really not going to spend any time on this, I'm going to skip both Powder and Cosmos, were the two that were established in time for the ORAN community to sort of say, to approach us and sort of say, hey, can we sort of look at the both labs or both deployments to become a OTIC, right? Or at least candidate OTIC, because that's not right. Now, the history, a little bit history of this. In 2016, we were hosting in part of Orbit, at that time Cosmos didn't even exist, the proof of concept for the ONAP. And at that time it was actually called the ONF, or Open Networking Foundation Wireless Transport Proof of Concept, where, and this is where you see the Orbit Lab and a lot of vendors sitting sort of in a round table fashion, bringing their equipment, plugging it all together and trying to make it work, right? And it was quite interesting because at that time it was sort of millimeter wave stuff that was interesting. And you can actually see the new cases that were directly relevant to the emergence of ORAN that came after a few years, right? Now, if you look at how the ONAP, which is the successor of that test, looks like, it's actually now extremely elaborate deployment that's sitting in the lab in both Powder and Cosmos, where you have a fairly non-trivial number of physical machines on top of which you have all these virtualized techniques, and then absolutely a crazy number of VMs, containers, and other software elements, to which various vendors attach their physical devices, right? And that's the idea of having a permanent deployment of some equipment, and then these periodic plug-fest and proofs of concept happening. And actually, plug-fest is happening right now. Today is probably the last day, and we have some vendors here in the lab. Unfortunately, I can't talk much about the plug-fest results because that requires the official release, which is going to happen hopefully in the week of December 6th. And then after that, people will probably see a public statements from various companies as to what was achieved during the testing. Now, again, how does it look like? You can actually see that there is a fairly significant resources that are dedicated to it. What's interesting to point out here that there are actually 3 parallel deployments, right? One is what's called a stable, where you have a permanent or something that the community considers a current version or operational version of the ONAP. You have the experimental, which is sort of something that people can appropriate for a short period of time and do crazy experiments with. And of course, you have development, which is where the main developers are pushing development of the code. Now, I'll just skip this slide in the interest of time, just to show you the plug-fest in its current form, meaning the one that's going on right now, which is the plug-fest 3. You can actually see that there are all these vendors that are participating, and the 3 sort of main hosts, what were called the hosts, which is Verizon, AT&T, and TIP project, and the 2 labs, Rutgers and University of Utah labs, that are sort of providing facilities for these tests. Now, history of ORAN plug-fest, in POCs, actually, I will now switch focus into POCs, which are way more interesting from research perspective, right? Is to sort of go through these use cases that are not necessarily on the main part of the ORAN development or ONAP for that matter. And one that we are doing right now as part of this cycle is this notion of multi-operator, sort of coordinating or orchestrating multi-operator environments in case of disasters, right? And so I'll just spend a few minutes on sort of going through this particular POC. And actually, this was fully demonstrated not just as part of ORAN, but also as part of Telemedicine Forum, where we were sort of showing this as a catalyst solution for emergency management. And of course, as you can imagine, DoD sort of has a big sort of interest in something like this. Now, as part of this POC, we were lucky to have AT&T guys and Powder guys sort of work on the full automation and deployment, as you can imagine, having a fairly large number of virtual machines, Kubernetes, and Docker containers, right? It's non-trivial exercise to try to deploy this. And so for that matter, the deployment was fully automated for the POC demo, and I believe shortly there will be a Powder Lab tutorial or template for deployment of the full ONAP plus ORAN deployment. Now, of course, the problem there is that, you know, we still are missing a permanent deployment of DUs and RUs that vendors are willing to give us. But, you know, hopefully both or all four Power Platform testbeds will soon be able to attach some of those to as a part of permanent deployment. Now, talking about this particular POC or proof of concept, and you can clearly see that this is sort of important from the point of view of multi-operation is if there is a disaster, right, chances are parts of the networks of all the operators are going to go down. And the question is there a way for systems to recover, especially in order to support the emergency personnel and issues that are related to that, first responders and stuff like that. And for a lack of better name, I'll call it FirstNet, but you know it applies to it has interest beyond the U.S. and then sort of especially in Europe, where you have probably border regions where there are way more than 2 or 3 operators in place. So just very quickly going through the situation. So you have 2 SMOs, and you know, think Verizon or AT&T, of course, we call them here A and B, that are operating a network in certain parts of the country, right? And during the normal operation there, they each control their own, they have their own SMOs, which are managing the network, and everything is fine. Once the disaster strikes, right, both operators or multiple operators are going to lose their capabilities, at least to some extent, and that goes both in terms of networking as well as in terms of wireless coverage. And then FEMA, or agency who is in charge of disaster management, is going to detect that and sort of say, hey, guys, we need to reclaim resources, right? And therefore, we are going to send a message through something that's well established in the industry called Common Alert Protocol to sort of say, hey, guys, we are running out of resources. We need to capture, we need to sort of service this area. Let us instantiate our own SMO, which is then going to talk to the other 2 SMOs and reclaim resources that are necessary to establish a full connectivity for first providers, but as well as other people who are involved in the disaster recovery. And again, this is sort of something that's today pretty much impossible to do. And the way it's done is, of course, that these FirstNet systems have their own deployment and implementation. But with the new approaches, with the disaggregated software-based approaches, it's quite possible to actually create that. And this is the POC that we're showing right now. We have 3 SMOs here in New Jersey, 3 SMOs in Utah. They're connected over the network, and of course, there's hopefully never a disaster that spans that wide an area. But nevertheless, it's sort of showing the capability where we can coordinate these 6 SMOs. Here is an example of actual configuration, and you have the CUs, DUs, and RUs, and it's just showing the complexity of what we're talking about, right? And I'm sorry, I'm rushing because we are running out of time. And this is an example of message flow that's happening between these entities in order to actually achieve this. And remember, the idea here is that the first responder SMO is actually grabbing resources in a temporary fashion, coordinating with other SMOs, and then, of course, once the disaster is over, it will return the resources back. Just showing some of the outcomes or some of the demo results on the during and after its disaster, and of course, coming finally to last slide, which is sort of where now all these vendors and operators really like the idea. They like the way these both PlugFest and POCs are happening. And they're sort of talking about lab as a service. It's sort of, they want to look into not just these two, but all the other major NSF initiatives on testing and testbeds, and sort of try to come up with a concept of lab as a service where various POCs and PlugFest can be happening in all these labs. And so this is where I will stop. Since we're running out of time, and if there are any questions, please let me know, and I'll happily answer it here.
Thank you very much, Ivan. Thank you. Thank you for the great presentation. We have some questions coming in, specifically from Michael. Michael Seguin, for ORAN, there is a need to have a deep understanding of the 3GPP standards to do modifications to the network. Now with XApps, there is a vendor-managed component that adds into the complexity where there could be thousands of XApps. What are some of the research areas that researchers can focus with ONAP that don't require decades of background 3GPP knowledge?
So I think there are actually two things there, right? So one is when you think about XApps, the biggest issue, right, is the scheduling, right? In the sense that you are scheduling or resource management on the compute level, right? So think in terms of, especially in a fully disaggregated case, these XApps could be all over the place. So one has to figure out how to coordinate both in terms of networking capabilities and computing capabilities, which is not necessarily easy. And then a second part to that is really what is the information that's needed coming from both the bottom and the top that XApps will need to in order to be able to optimize things. And when I say optimize, I don't necessarily mean closed form optimization. This is probably an AI ML problem in a sense that we don't necessarily fully understand when these measurements and feedbacks from the bottom come up, how they can be used for optimization. So that's pretty much what I think would be the